Hello everyone, my name is Ankit Kumar. I am going to represent FPGA project on CORDIC algorithm under Suman Samui sir. Contents of my presentations are introduction, theory and concepts, CORDIC modes, CORDIC applications, FPGA implementation of sine and cosine functions, CORDIC multiplication and division, future scope, conclusions. In the introduction, the CORDIC algorithm, the CORDIC word stands for the coordinate rotational digital computer, and uh, it is it is the iterative approach focusing on the precision and efficiency. In this project, we are going to demonstrate or implement the CORDIC algorithm using the Verilog coding. The coordinate rotational digital computer is a specialized digital computing technique designed for the real-time applications, especially in the airborne computations. It is mainly used for the trigonometrics functions calculations, but it can also be expanded to calculate the more precise functions such as hyperbolic, exponential, and other multiplication and division computations. So the CORDIC CORDIC will work in the two modes, rotational mode and vectoring mode. In the rotational mode, the new coordinates components are calculated after rotating the original vector by a given angle. In the vectoring mode, the magnitude and angle of the original vector from its coordinate components are computed by going nearest to the y is equal to 0, that is x-axis. So in the rotational mode, so uh, this is the equation we got for next computation to next values of x and y to be x, y and z to be computed. We have to check the sign of the theta. If sign is greater than 0, then sigma will be taken as 1, otherwise it will be taken as -1. Similarly, the micro rotations in the rotational mode will be happen in terms of uh, if you want to go to that particular theta degrees, we have to do the certain micro rotations to go to the as nearest as possible to that particular theta value. So we use the predefined values stored in the lookup tables. In the vectoring mode, this is the values after the computation we will get. So as the y-axis, we are going to do the computations until unless we get the we will reach the y is equal to 0, that is x-axis, and the sign of the sigma will be decided by the sign of y. If y is less than 0, it will be taken as 1, otherwise it will be taken as -1. So again, the micro rotation will take place in the vectoring mode also. We should take we will get to the nearest value of the y is equal to 0 axis, and we will use the predefined values in the lookup tables. This is the unified description of the CORDIC algorithm, in which the all this generalized expressions of the next computation will be given. Like if you want to calculate the next computation of the x, depending on the previous values, we have to check certain things, like which coordinate is to be used, and which mode is it is using to calculate, like rotational or vectoring mode. So according to that, we have to give the we have to define our Verilog coding according to the applications of that CORDIC algorithm. Again, the main thing is we have to come up with the scaling factor also. So scaling factor comes with the after doing the certain micro operations, it will not get the ideal value. It will be scaled with some error or the unwanted value. So we have to com we have to overcome this uh, scaling factor some data with the our predefined initial values or in the final values. So this is the mode of my CORDIC algorithm. I can use the CORDIC algorithm in a different way. Like here, if I am using the circular coordinates, so I have to give m is equal to 1. But I can use the rotational mode and vectoring mode according to applications. Like in the rotational mode for circular, it is used for the sine and cosine calculation, and vectoring mode it is used for the magnitude and phase calculation. Similarly, in the linear mode, the rotational mode is used to calculate the multiplication like x into z in, and the vectoring mode is used for the division like y in upon x in. Again, it can be used for the hyperbolic mode also. This is the other functions. We have to give the initial value to reach to the certain values. This is the implementation data path architecture of the CORDIC algorithm. So certain iteration based, it is the iteration based architecture. So we will need four main blocks to use in the CORDIC algorithm. First is marks, second is shifter. It will shift the particular data with I as Z bit. Adder and subtractor, it will depends upon the sign of the particular process, like for the rotational and the vectoral fold, and the register part in which we have to store the values. Here the table is used because the predefined values are also needed to compute the z values. So computation of sine and cosine. So in this project I am going to demonstrate the sine and cosine functions using the rotational mode. So in the rotational mode, if I want to get to the cosine and sine value, I need to give the x is equal to 1, y is equal to 0, and z equals to input theta. The theta will be my input theta. For that, the sine and cosine theta will be calculated. So here's the one trick. If you want to, if you are giving the x is equal to 1, it will not come as a ideal values, because the scaling vector is also there. So we have to divide the final values with the scaling factor. This is the data path of my CORDIC in the rotational mode to demonstrate the sine and cosine, in which if I want to demonstrate in the FPGA board, I have to give the values to the theta values to the FPGA board RTX 7 chip, because my Verilog coding is coded in the RTX 7 chip. So I have to give the values to the input values to the gate, because I can't give that fixed values inside the by using the switches. So I am using the lookup tables to give the input values, and I am selecting the mode select. So which mode to be selected, like for the sine theta calculation and the cos theta calculation. Again, we have to use the certain modules to demonstrate on the FPGA board SSD displays. Now the multiplication and division using the linear CORDIC algorithm. So in the linear CORDIC algorithm, we have to give the m equals to 0. So if I am using the rotational mode inside the linear coordinates, I can get the multiplication after giving the x is equal to a, y is equal to 0, z equals to b. So final value will be computed in a y. So the final will be a into b. Similarly, if I am using the vectoring mode in the linear coordinates, I will get the division by putting the x is equal to a, y is equal to b, z equals to 0. this will work fine, but we have to come up with the scaling factor decomposition also. This is the data path of CORDIC in a linear mode. Same thing, we have to give the LUTs to give the inputs, and the select the division and multiplication function. So future scope in the CORDIC algorithm, it can be used in the DSP, digital signal processing blocks, embedded systems, hardware efficiency. Pipelining is also can be done, because here in this circuit my design is not pipelined. Biomedical, communications, machine learning and navigations. Main uses. So the main uses are realization of rotations, calculation of trigonometric functions, calculation of inverse trigonometric functions, calculation of root over the magnitude functions, extended to hyperbolic functions, division and multiplication, calculation of square root, log and exponential, for linear transformation, digital filters, and the solving linear systems are also these are the applications. The conclusion is that in the summary, like we have implemented this CORDIC algorithm in FPGA 3 board, but there can be so many things we can demonstrate uh, in our Verilog code to use in different functions. I have implemented sine, cosine, multiplication and division only, but there can be also other implementation can be done in the uh, after doing this work. So that is the conclusion, and it is widely used for we have achieved the robust computation capabilities suitable for myriad of applications. Thank you. Everyone, here I am going to demonstrate my project on basis 3 FPGA board. My project topic is implementation of CORDIC algorithm in basis 3 board. So here I am going to demonstrate the CORDIC linear mode, which can demonstrate the sine and cosine functions. Here I have declared three switches for mode select, we, uh, which can select the theta degrees input to be calculated, and fourth switches uh, is to is to be used for the sine and cosine functions selection. So here if I want to calculate the sine functions, I have to give it as a 1, because I have declared as a 1 for the sine and 0 for the cosine. So here in this, three switches are for the all the three switches are for the degrees selection. So in the all, if all are zeros, so it will be selecting 0 degrees. So sine 0 degree will be 0.00. This 6 is there will be because the iteration count is low. If we increase the iteration count, it will be get more accurate going further. So if I apply the next input as a 30 degree, it will calculate as 0.5, 45 degree, 0.7, which is 1 by root 2, and 60 degree, which is 0.8, with, that is root 3 by 2, and 90 degrees, which is this one. So